Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode challenge 916, word subsets. This question has been asked in Google and Microsoft recently, and it is based out of string concept. Let me explain the problem statement to you with the help of an example. Here, first of all, let's see what is given to us and what we have to return. As a given part, we are given two string array. First string array is words 1 and second one is words 2. And what we have to return is return an array of all the universal strings in words 1. And you can return answer in any order. Okay. These two strings array are given to us and we have to return all the universal strings in words 1. If we just skip the word universal, return the array of all the string in words 1 and in any order. Okay. See. So what we have to return is from this array, we have to return a couple of strings which are universal. Now let's try to understand what is a universal string. And universal string will always be from words 1. It is mentioned as per the problem statement. We have to choose universal strings from words 1. See, universal string is from the word 1. Let's say the string name is A. So every string in words 2 is a subset of A. If every string in words 2 is a subset of this string, then this string A is universal string. So let's say if I pick a string from words 1 and if I want to see whether this string is universal or not. So what I will do is I will check whether all the strings from words 2 is a subset of this string. Now the universal string is clear to you. What is universal string? And let's try to see what they want to say with this word subset. What does subset mean to them? So let's say if two strings are given to us, string 1 and string 2. If every letter of string 2 is present in string 1. Let's say in this case, what are the letters from string 2? E, C, O. E is also present, C is also present, O is also present. All the letters from S2 present in string 1. It means then string 2 is a subset of string 1. Pretty simple. That every letter from S2 is present in S1 and including repetition. If I am having 3E, then every E should cancel out every E from S1. This E for this one and this E is also utilized here. And this E is also utilized here and CO is also present. So all the letters from S2 present in S1. Hence we can directly say S2 is a subset of S1. Now subset is clear to you. And universal string. If any string from words 1 is universal, let's say Facebook is universal if every string in words 2 is a subset of this string. Let's say first string is E. Every character in E, every letter in E should present in Facebook. Okay, E is present here. Now, E is a subset. Yes. Let me do a tick mark. First string is a subset. And what about the second string? O is also present in this. Every letter is present in the word 1 string. So O is also a subset. If all the string from word 2 is a subset of word 1 string, then this string is called universal. So from these strings, some string will be universal and some strings will not be universal. Let's say what about Amazon? Here Amazon, E is not present. This E is not present in Amazon, so it means there is no need to check further. This is not a universal string. So what about Apple? APPEL. APPLE. Okay. O is not present here. So this is also not a universal string. Not a universal string. In Facebook, E and O both are present. Both are subset. Yeah. Universal string. This is also universal. This is also universal. So we have 3 universal string. These 3 are the universal string. And what we have to return is just return array of universal strings. Okay. So what we will return is we will return a list containing Facebook, Google and LeetCode. So this is the problem statement. Let's also have a look on the constraints. Here all the strings are lowercase English letters. It means they will contain letters from small a to small c. Only 26 possibilities. Words I don't length, words I dot length. It means length of every character, every word is going till 10. But length of this array can go till 10 raised power 4. Words one array can go till 10 power 4 in length, and this can also go till 10 power 4 in length. Now the problem statement is clear to you that two arrays will be given to you and you have to return all the universal strings. Now let's try to build the approach. As per the problem statement, we have to get all the universal string. So we definitely have to iterate over this string array, words one. Let's say we are on a string A, and A is Facebook 0, 1, 2, second index string. And now I need to know whether A is universal or not. To check whether A is universal or not, we need to see that every single string from word 2 is a subset of A. And how can we check that? Subset means every single character in this string should be containing in this string. Let's say this is B. We are going through every single string and that is B. So A is our Facebook. And B string currently is E, just containing only one letter. And now you need to build an approach whether you will be able to tell me that whether this string is a subset of this string. And subset means that these letters is already present in this string. And as per the input constraints, we are told that we are going to have only small case English letters for this word. It means only 26 possibilities. If you only 26 possibilities, why not I just take a hash of array of 26 size and mapping every single letter with this indices. A is mapping to 0 index, B is mapping to 1 index, C is mapping to second index, and like this. This is for 25th index. And now I can store the count. A is coming only one time, B is coming only one time, C is coming only one time, and so on. And then I will also prepare a hash for this array, this string as well. In the same fashion, A, B, 0, 1 and Z for 25. Let's say this hash is H and this hash is H1. So if every value A, B, C, D, E, E is at 1. So C, then D is coming 0 times and then E is coming 1 time. Okay, then every value, if the value is not given, then it is 0. Every value H1 I. H1 I is the ith value of in H1 and HI is the ith value in H. So to be able to subset for E, to be able to subset of Facebook for every I, H1 I should be less than or equal to HI. This condition should fulfill. I hope you are able to understand. Let's see. I am just comparing whether this H1, this array can be contained in this array. So if this is true, then yeah, this is a universal string. This Facebook is a universal string. And when it is universal, not just for E, if for every single string in words 2, if it is true, then it is universal. Otherwise, it is not universal. So if at any moment, if this H1I is having value greater than HI, then we can directly say no. And we can stop the comparison as well. Okay. Now it is clear that for every string, let's say n times, we have n string. For every n string, we can match it with every m strings and see whether that string from m is a subset of not. Now what is the time complexity of this approach? For every string in the word 1, I'm matching it with every string in the word 2. So these n and m value can go till 10 to the power 4. And what about this matching algorithm? These matching algorithm are not going to take any extra time. So these are order of 26. So in short, this approach is going quadratic. You can write this approach and try by your own, and you will see that you are going to get TLE on couple of cases, because we are iterating on every single word in word 2, and we are given that if any one of the word is not a subset of A, if any one of the B is not a subset of A, then it is not a universal string. So it means for A to be able to universal string, every single string from word 2 should be the subset. If every single string should be the subset, so these hash we are preparing for every single B. For B1, let's say for B1 we are having H1. For B2 we are having H2. For B3 string we are having H3 hash. Why don't we just combine all the hash functions for every B strings? How can we combine? We just need to see whether every single string is inside this A. So we can combine with every possible maximum value at every index I. Two strings were there. E is coming one time and O is coming one time. So we can have a combined hash. These are two hashes. We can have a combined hash where E should be coming one time and O is also coming one time. We can use this combined hash to compare whether this A string is universal or not. Okay, so what I'm trying to say is that instead of going through this M array, do some kind of pre-processing on words 2 to form a combined hash, so that we will be able to tell whether the A string is universal or not in order of 26 time, and we are having n strings in words 1. So ultimately the time complexity will go order of n. So this m iteration, so only the main iteration we are doing. So this m iteration we are doing only once in the starting. So instead of n into m, it is going to be m plus n. So from quadratic, we are converting it to linear. And you will be able to submit this problem on LeetCode. So this linear solution is going to work. And what about the space? Order of 26. Order of 26 to store the character frequency, and that is considered as a constant space. Now let's code this approach. First of all, we'll do some kind of pre-processing on words 2. It means we will be iterating every single word of words 2. And as we have decided in our approach, we are going to have a common hash function that is going to contain every single hash from string to word. That will also be of size 26, new integer 26. Let's say this is the hash for every single word. We are processing S from words 2. Character ch s dot to character array. What I have to do is character minus A. A is going to be stored at index 0 plus plus. Now this is the hash for the current word, and this current word, I'm not bothered about the current word. I'm just going to maintain my common hash. So for the common hash, just run a loop of 26 size, I less than 26, I plus plus, and this hash, common hash of I is equal to math.max hash of I comma hash of I. This is the hash for the current word, and this is the common hash. Okay, now after this point, we are having a common hash function for words 2. Now we have done the processing and we will be iterating on every single word in words1. String, let's say call it as words1. Okay, whether this s is universal or not. So for that I need to prepare a hash. Let me use the same logic. Hash new size 26. This is the character array. Okay, now this word will be universal if this word hash contains this hi. If, let me write another function, subset, and what is the current hash from the a string, and this is the hash for the b string h. If this is true, then I'm going to add result dot add s, this string in my result. Okay, and in the end I have to return the result. Okay, apart from that, do I need to do anything? Let's try to implement the subset function. Private boolean subset integer array hash integer array h. For I equal to 0, I less than 26, I plus plus. I will just write a negative case. So in the end, I can directly return true if there is no negative condition getting true. If h of I is greater than hash of I, it means that all the words from words2 are not subset of the word from words1. In this case, just return false. First of all, we did some pre-processing and we iterated on every single word in words1 and checked whether this word is universal or not. Okay, now let's test by submitting, let's run over sample test cases. Sample test cases are passed, I'm submitting the problem. It's submitted successfully and it's a linear time solution. If you have any doubt, you can comment down below. I will be happy to help. Thank you guys. Bye bye.